What up, you awesome sauce hackers? It's your boy, the humble hacker from Chi-Town, Shy Ronin, back with another walkthrough, and this time we'll be tackling Buffer Overflows. Now, when I first got into pen testing, just the thought of learning Buffer Overflows always made me want to take scary showers, as I always picture them as some kind of nightmare fuel, like Freddy Krueger or the Candyman pop out and say something like, "Welcome to Stack 86, bitch." Now, after I read the guide for this room for about the one sec, hold on. Carry the 2 divided by 4 times 6. The 26,487th time? Yes, I counted. I suddenly realized this is flippin' cake. Why was I crying with the anime waterwork eyes about this in the first place? This is easy work. Which leads us to today. I will show you the process I forced myself to learn. The dope part is that once we get our flow for the steps, it'll be smooth sailing. We'll be using the TryHackMe room Buffer Overflow prep made by the always amazing Tibris. Wanted to make the presentation for this a little fun, as I had to get creative on how I had to make the topic easy for me to understand. Now, without any further ado, let's get it. Hello, friend. Welcome to my presentation on Buffer Overflows. That's enough of that. Hey, everybody, what's going on? Let us have the fun beginning. Now, what is a buffer overflow? Now, the semi-technical definition would be a way of writing data to a memory of a program that exceeds what it can handle and overrunning that application, causing it to crash. During said crash, an attacker can add on their own code in order to get the application to do whatever it wants. Primary case, making a reverse shell, creating ownership over the application, and making it the attacker's. Okay, kind of threw me off a little bit, but that's why we have story time. Now, I don't want to play any music in the background because I don't want to get any flip mode squad and copyright strikes, so we will just be envisioning ourselves driving through a how the hell you pronounce that damn word? You know what? Neighborhood. We're just calling it that. So, as you're driving along this neighborhood, this is the equivalent of a program. And in this neighborhood, there is a medium-sized store that is, let's say, it's the backbone of this application. So you're driving around and you hear the classic, Leave It to Beaver soundtrack or Andy Griffith playing in your head. And let's just check out this store, which is the main program here. What is in it? It could be anything. It could be groceries or electronics or maybe a dollar store. That could be something. Or just things that have little knick-knack, paddywhacks, get a dog a bones. Look, we have this program will have a nice flow of data where traffic can come in and out and go wherever it would like to. We would have new processes. Look at these little kids getting ready to go and see what this store has to offer in it. We also have data organization. Look how nice these things look. What is this? What's the word? What are those? Preserves? Ooh, those look a little nice and organized and handy. We have data transactions. Hey, Sally, thank you for this bag that is very reasonably priced. Where in other stores, it would probably be marked up maybe 100 to 232%. This is such a fantastic town. Uh-oh, looks like we have a spill. Looks like it's a data error. Here comes Brad to the rescue to go ahead and clean up those errors and make sure that this store or main program is operating at 100% capacity at all times. Thank you very much, buddy, for being a friend. Anyone know where this might be referencing? Give you a good 5 count. 4, 3, 2, 1. The Golden Girls. Yeah, I probably only watched maybe like 4 episodes of this. I was a kid with ADHD back then. The possibilities are endless for what a program can do. But now here's where the bad part comes in. Start to hear some sounds coming from the distance. This is new data. Could it be tourists? No. This is where we insert the heavy metal rock music. It's an army of evil frat boys named Chad. Oh my damn, this is bad. And all these evil Chads get out of the tour buses and bum rush the store, overflowing it with evil Chads. And the evil Chads take over the store, making the store not being able to function. There's human sacrifices, dogs and cats living together, just mass hysteria because the Chads have overrun the store. Damn those Chads. How did this happen? Well, that's what buffer overflows are. And that's what we will be learning. So let's find out how to do this together, shall we? We will be using the TryHackMe room, buffer overflow prep, and we'll be just using the this first example. We'll go down the steps, and then we'll utilize the tools that will be that will provide us with the immunity debugger. We'll be learning how to install and add and set our folder for Mona. I will be showing script templates that I use for here. I will use Terminator. You can use whatever that you like. I just like this because I can just make all of my terminals I'll be using just in one spot. I think there's Tmux. I still don't know how to use that damn thing, but I'll figure it out. Here's basically the screenshot of what we'll be looking at in Immunity Debugger. So this, the upper right, here's where all of our registers are. The main focus is going to be the EIP. Yes, that is fuzzy, I know, because I had to enlarge a very small image here. And our ESP, which will be right here. The lower right shows like the stack and all of its contents. These are kind of like similar to each other. And here's all of the actual like instructions from the application that we'll be keeping an eye out for just a little bit. And the Mona application, not this one, is going to be a Python program that I should hopefully be able to have a link for and not get flagged for that. And this is basically what it is. This is a Python script to help with the buffer overflow process. It works with Immunity Debugger, showing how to, and I'll show you how to get that set up and configured. And here is my terminal setup here. I have one that would just be for the fuzzer. You have another terminal window to find the offset. Then I go through finding the bad characters. Then I make my final payload where I could get a shell over the system once I use all the data gathered from these three, and I'll put them here. Okay, after all of that, it is time to begin. Are you ready? Hopefully I am. I will see you in the next video. Alright, now let's begin. The first thing that we're going to do here, we're going to RDP over into our working Windows system. It's going to be Windows 7. To do that, we're going to use the application xFreeRDP. So we have xFreeRDP, specifying the username, specifying the password, ignore a certification verification, and here's the address that we're going to, and we're just labeling it as our work area. So here is our Windows system, and here is our Immunity Debugger. Now, the first thing that we need to do on this machine is make sure we have, whoops, did not mean to do that. There you is. Make sure that Mona is here. So let's go over to our computer. We'll see. And then we are going to our Python and our no. So I forgot that one. I think it was. I thought it was this one. All right. We have to make sure that Mona is installed, which I don't believe it is. So wait, actually, Mona would have been in here. My bad. Okay. So let's go ahead and get that. Okay. Let's go ahead and connect here. Which actually, hang on one second. My bad. I need to double check. I think Mona was already here. Because I do not believe that this can reach the internet. Scheisel shoozles. Okay. Immunity. Yep, it's in this folder, the Pi commands. Sorry. And there we go. Alright. Mona's here. So we don't have to worry about this chart. My bad. So let's reopen this here. And we're going to create a path for Mona. So let's go and do that down here. Going to use the exclamation point Mona config. Set our working folder as C Mona %P. Okay, we've just created our folder here. Okay, we do have this compiled. And where's our freaking Mona folder at? Let's just go ahead and just make one. Okay, run this again. Okay, so now that we have Immunity Debugger open, let's run our application, which is going to be from, wait, there we go. Let's go to desktop. There's our vulnerable apps, OSCP. Let's go ahead and have it connected here. We're going to run it by hitting the play button. Okay. Now, we're going to run, first we need to, now that we're running the application and we can actually like connect to it, we're going to need to netcat and specify that we are going to be working on the Overflow 1 lab. So we're going to run nc for netcat, get our IP address here. And this is on port 1337. All right. So we have enter in help. And here are the overflow commands here. We're going to simply type in overflow 1. Get rid of that caps lock. I said get rid of the caps lock. There we go. Test. Overflow complete. This is saying that we have successfully connected to this here. It is running. As we see here, we got our command prompt saying it's waiting for connections. Right? Let's go ahead and minimize that. So now we can exit out of this here. Okay. Good. So we go ahead and close that connection. Now for our fuzzer file is going to be this one here. We're specifying the IP address. The only thing that we have to really change is just the IP address right here. And as we see, it's going to be connecting to this IP address on this port. Timeout if it can't connect or not after 5 seconds. We're specifying the lab that we're working on, Overflow 1. And the string that it's going to send is 100 A's. Then it will tell us where it will crash at as it's printing the number of bytes, which I believe start from 100. So let's go over here, run our Python fuzzer pi, and nope, forgot it's supposed to be Python 3, and there we go. Now while this is running, we'll see here, this is all of each of our connections here. Then afterwards, this will stop. This will change from running to paused, and it'll tell us where it crashed at. Okay. And normally at this point, we have a solid prompt. It crashes there. Exactly. So we have crashed at 2,000 bytes. All right. Now that we have that, as I'm saying, this is going to be, so pause once it crashes. That's correct. We can close this out. We can restart this application, which will reopen this, run it again. Okay, now we're not going to do anything to this one yet. So now that we have this one crashed at 2,000 bytes, next up that we have to do, we have to create a pattern to add to our next script, which will be finding the offset. All right, and this is our template, and this is us finding the offset. So let me go ahead and drag this all the way down over to the end. Okay, so finding the offset, we're going to go user share Metasploit framework tools exploit pattern create, and we will create the length with -L an additional 400 bytes over where it crashed at. So here we're going to be using 2400, and it's going to be creating a pattern of 2400 bytes right here. So we're going to copy this, go right over to our offset template. Then we're going to put this into the payload here. Paste that right there. Save it. All right. Program is already reran. All right. So the one that we're going to be running is this one, the find offset. So Python 3, and that is the exploit find offset. Run that. This should crash, which it does. Okay, and we see our overflow here. All right, now we have a successful crash. Now we're going to find the distance by using Mona find MSP distance and the length pattern that we created. This is to confirm that the application crashes from our offset. Now we're just going to see what this offset is from here. What was the EIP offset? This is our instruction pointer, the main focus number that we're going to be working off of, which is here. So we have 1978. Our EIP possesses the offset of 1978. So we're going to switch this, and we're going to add, let's see, if triple click works, which it doesn't want to. So I'm just going to use this instead. Now our offset was 1978. So we're going to put 1978 there, and we're going to set our return variable to 4Bs. What this is going to do is going to run this exploit with this offset. So with 1978 A's, so the next 4 bytes after that should be these 4 B's. Okay, so we're going to restart this application, rerun it. Okay, over offset, we confirm that it's running, which it is. Go right up here. And we're just going to do template, run it. Okay, went through. This should crash. Just wait for it to crash here. Okay, what the hell? Oh, wait. Oh, stupid ass. I didn't save it. Duh. Alright, let's try this again. Let's run this one more time. There we go. Now it crashed again. So, the overflow consisted of the amount of A's times the offset number. So, this is basically saying we should print 1,978 A's, and the 4 bytes after that should be 4 B's or 42424242. That's 4, right? 42? Okay. 42, which we have right here. So this is basically saying that we are correct in having our offset number and our EIP recognizing that it should be having 4 B's right there. All right. Now, next up, bad characters. This one is going to sound a little bit confusing, but this is where the ping-ponging begins, and this is where it gets a little bit fun. So, what we're going to do, we're going to first run our bad character script, or bad chars, if you want to call it that. It'll print in hex 1 through 256. So, let's go ahead and run this. Crapsies. Alright, we're gonna remove the null byte, since that's normally the first number that we always have to get rid of here. Now, we're gonna set our offset 1978. Our return variable will have 4 B's in it. The payload, which should be enclosed in parentheses, however it is you want to pronounce that word. And here's are the bad characters here. Now, here is where it gets interesting. For Mona, what we're going to do here, we're going to generate a byte array. So byte, Mona byte array, removing the null byte in Mona. So we're saying that we are generating a byte array for this application, but we're removing the null byte of 0 for here in Mona. As you see, command worked, and this file here should be, here we go. So this byte array, we just created it. This is this one right here. So this created a byte array in Mona that says it will have all these characters in it except for a null byte of 0. All right. So now that that's done, we start the application. We hit play. Go over to our terminal here. Clear this out. In this one, we're going to be running the bad characters. Python 3. Oh, whoops. I put it on exploit. Whoops. Bad chars here. Make sure that this is saved. Yes, it is. And we run it. All right. Ran it. Crashed. Okay. Read 4 B's. Now, what we do is we look for our where our bad characters are at. And what we do is, where is that? Okay, we use Mona, obviously. So we're going to run the compare command, compare this crash to the byte array, and determine what bad characters it found, what other bad characters other than the null byte that it found. So we're going to run dat-f, and the path to our byte array script, that's right here. So we got C, Mona, OSCP, byte array dot bin, this file right here. And the address is the ESP register right here. So we can double click that or just single click it. Right click here. Copy selection to clipboard. Paste it right here. And it'll show us what bad characters it found. So corruption after 6 bytes. So we have our null byte. And possible bad characters is 07. So here is the ping ponging that we do. Go back to the drop down. Come right over here. Simply add the next null byte character. Hit enter. Add 07 to the byte array. Run the program. Go to our bad characters. Remove the bad character that it found. You have to do this one by one. You can't mass do this here, because if you do, you will miss where these may have like false positives for other characters, but we won't know. And the only way to determine that is if we go one hex code at a time. So we just remove 07, save it, come back here. It's already running. Run the exploit again. Go back to RDP, confirm the crash. Now we have a new ESP offset. Copy the selection to clipboard. Click the drop down. Go to byte array. Now this is already here, so all we got to do is paste it. Get our new results. Possible bad characters 2E. All right. So what do? Come right back here. Go back to our byte array. X2E. Add that to the byte array. Hit enter. Reset program. Play it. Go back to here. We removed 2E. So let's find where 2E is. It's right here. Save it. Run it. Smack it up. Flip it up. Rub it down. So we have a new ESP offset. Starting to see the ping pong pattern right here. So it makes it so much more efficient just to go down this way. So we got copy and paste our new ESP, new byte. Now it's A0. Okay. So bring back up our byte array. XA0. Hit enter on that. Come back over to this one. Actually, nope. Restart the program. Just like that. Run, boo! There you go. Go back over here. You just removed A0. So let's find A0. That would be right here. Save it. Run it. Switch it. Flip it and reverse it. Now we have a new ESP. Copy that. Go back to our byte array. Hit enter. Now we have unmodified. Now, you did see that we did have additional characters in here, but this is also the reason why I said we have to go one by one, because because this says there's a potential bad character does not mean that it actually is. And this is how we determine that. Now we find that that there are no more bad characters in the script here, which means that our discovered bad characters are these here. 0, 7, 2E, and A0. Now, we can take this here, go over to our payload here, and that would be this one. Now we enter everything that we have found so far. So, when we now take our script, we have to turn the script little Indian for our bad characters. Actually, hang on one second. Let me make sure I'm doing this correctly and not missing anything. Actually, wait. I think I may have missed something here. Let's find our jump point. Sorry, totally forgot all about that. we go. All right. Okie dokie. So we have JMP, RESP. I forgot what these were, but enter our null bytes here. Where's, hang on. Should have populated over here what our ESP was. Or what our jump point address was. Sorry about that. Let me see. Let's look for our log data window, since that's where else it would be at. Okay. Here we are. So, but looking for a jump point, we find find 9 pointers. Okay, sorry about that. All right, so let us pick any one of these. Start from this first one. Shrink. Got a little bit lost in the sauce myself. Here we go. Okay. Totally forgot this jump point step. Totally my fault. So what do we got? We have 625011AF. All right. So we will use this address and put this into our return variable, but in Little Indian. In Little Indian, these are our back characters. This is the pointer we're going to be using. In Little Indian is going to be this set of characters, but in reverse. So we have X, AF, X11, X50, and X62. Next up, and with this here, we will use our MSF Venom to generate a payload of a reverse shell. So we're going to go ahead and enter MSF Venom, P to specify our payload, which is going to be, Windows, not WinPose. Going to use a staged payload, reverse TCP, specify our host and our port, exit function thread, format Python, and our null bytes. Wait, where'd it go? There you go. Okay. And F C. And let's find our addresses here. Okay. What port do I want to use? I don't know. Maybe 1, 2, 3, 4. And this is supposed to be a C, not a V at the end of it. Dang it. There we go. So let us create. Sure. Where's our payload script? That is this one right here. All right. So for our final script here should have our, let me see. I know I'm missing a step. So let's figure it out together. All right. We're generating our payload here. All right. We're just going to prepend some NOPs. Some NOPs. Not NAPs, but NOPs. Okay. Going to have a bunch of 90s. Not a bunch, but 16. obviously, right there. And where's our next one? All right, our payload will be the script that is generated. We have to change this to 1978 because that's our offset. We're going to remove our return address and just have our payload as this here minus the semicolon. Let's go ahead and scroll up there. Let's go ahead and copy that. Our payload enclosed in parenthesis. All right. And we should be good to go. So let us save this. Whoops. Set up our netcat listener. Run this application. And wait. Okay. Whoops. There we go. And run that. Sending evil buffer. Done. Made sure this crashed. Whoops. Wrong one. Okay. So we did not get our shell there. Awkward. Hang on. Solid Koisa. So we'll wait for this to blink. Which crapsies it is. All right. So if that one didn't work, let's try a different one. Let's try with MSF Venom with the Shikata Ganai. Shikata Ganai. I don't know, however you pronounce that. I don't know, damn it. So we're going to go Windows. Let's try this one next. Windows, shell, reverse TCP for this one. And let's copy this and paste it, but we're also going to edit it. So let's see. Let me get rid of these. We have our L host and our L port. Our exit function thread. Format Python. Okay. And where are our bad characters? Whoops. Wait. Oops. Sorry, it's over here. Okay. Have our bad characters. And E x86 Shikata Ganai. Just make this into shellcode. Locate our exploit script here. Make sure everything is still correct, which yes it is. Where's my notepad? There you go. Let's see. Now let's see where else we may have missed, just in case. Alright, so we already set this. We set up our padding. Yes, we did. Okay, we're setting up our payload here. So here's where we're currently at. What? Invalid payload. Oh, that's weird. How is this not? How is it not a valid payload? Let's check the spelling, because last one worked. Okay, error. Let's see if I remove the slash. Okay, so this may do something. There we go. Okay, so we have our netcat listener ready. Let me see. Ah, dang. Okay, actually, I think I may have messed this up. Let me look at this again. Alright, so we are enclosed in parentheses. Alright, have a return address. Let us run this application again. Alright. Okay, sent to equal buffer. Done. This application should, should show that it's crashed now. Okay, we have our 4 Bs there. Wait a minute. Hang on 1 second. Ah, stupid. That's why. Duh. Oh, shoot keys. 1 second. I think I was supposed to. Yeah, put the return variable. Yeah. Yep. I knew I was messing something up. There we go. Okay. Try this again. Dang it. Restart. Play that. There we go. Ha ha! Excelsior! There was our issue. So, we didn't put the return value, which was the number of pointer that we found here. Where the hell is that damn window at? Well, the address that we changed to the address that we found that we made Little Indian needed to go here in the return address for padding. And then we had our shellcode and our offset. Totally my fault. So our final payload was our offset and the pointer address that we got in Little Indian. We have our 1690s for padding and our payload here. And from that, we were able to gain our reverse shell here. And if we run who am I to see who we are on this, we are admin. Okay, so that was fun. Hopefully you guys enjoyed it as well. So this should be like a hopefully this was easy enough to follow and understand, and done in like a good way that was retainable. Don't forget to leave your comments and let me know if what you think of it. Don't forget to like, share, and subscribe. Stay updated on future content. I am Shy Ronin, and I am out.